Everyone, welcome back. Today I'm going to explain a problem on design for shear. A concrete beam of rectangular section 200 mm wide and 650 mm deep is pre-stressed by a parabolic cable located at an eccentricity of 120 mm at midspan and 0 at the supports. If the beam has a span of 12 meter, carries a uniformly distributed live load of 4.5 kN per meter. Find the effective force necessary in the cable for zero shear stress at the support section. For this construction, calculate the principal stresses. The density of concrete is 25 kN per meter cube. Calculate P for zero shear stress. Here in this problem, we need to calculate pre-stressing force to be applied in the cable in order to make shear stress at the supports as 0. Here figure is not given, so according to the data it's a rectangular cross section 200 mm wide and 650 mm deep. Half of it will be 325 mm. This dotted line is neutral axis, and about the cable it's a parabolic cable. It is having an eccentricity of 120 mm at the midspan and 0 at the supports, and it is having a length of the span is having a length of 12 meter, which is carrying a live load, and it's a uniformly distributed load having a magnitude of 4.5 kilonewton per meter, and density of the concrete should be considered as 25 kilonewton per meter cube. So let's see the next slide. For the calculation purpose, we required moment of inertia. So I is equal to BD cube by 12 for a rectangular cross section. Width is 200 into depth is 650 cube by 12. That will give you 4.57 into 10 power 9 mm power 4. Width is 200 mm. We required static moment of area in further calculation. So calculate A y bar. It is also denoted by S. A is area of the hatched portion. You can see here I have already mentioned it as y bar. So the area will be 200 into 325, the hatched portion which is above the neutral axis. Then y bar is half of this. 325 by 2 is a y bar. So we will get 10.56 into 10 power 6 mm cube. Next is dead load of the beam. Dead load of the beam is 0.2 into 0.65 into 25, that is cross section area. They have given it as 200 into 650, that was in mm. Convert it into meter into density of the concrete. In question itself they have given the density of the concrete should be taken as 25 kilonewton per meter cube. So cross sectional area into density you will get 3.25 kilonewton per meter, and the live load on the beam is 4.5, that is UDL, 4.5 kilonewton per meter. If we add these two load, dead load as well as a live load, we will get 7.75 kilonewton per meter. Next is ultimate load. This 1.5 is for designing. While designing, we should consider a factor of safety of the concrete has 1.5. So 1.5 into load is 7.75 is equal to 11.625 kilonewton per meter. In further calculation, we should be considering this ultimate load value, not this. So whatever ultimate load we have got, I have just shown by a sketch. Simply supported beam carrying a UDL. This consists of live load, dead load, and also a factor of safety. So we will get 11.625 kilonewton per meter, which is acting throughout the length. Then it's a calculation for ultimate shear force. Ultimate shear force, or yes, okay. For the ultimate shear force, the formula is WL by 2 for a simply supported beam carrying a UDL. And also the shear force will be maximum at the supports. So it is WL by 2 is equal to 69.75 kilonewton. W you should consider 11.625 into length by 2, you will get this value. Next is sine theta. Sine theta has the given cable profile is parabolic, and it is parabolic with concentric. Because of that condition, sine theta should be considered as 4E by L. That is equal to 4 into E is eccentricity at the center, or at the yes, at the center, exactly at the center or mid span. Eccentricity is already given, that is 120 mm. Consider that 4 into 120 whole divided by 12,000, convert 12 meter to mm, you will get 0.04 as a sine theta. Next is net shear force, that is denoted by VU. That can be found out by using these two values. First of all, I would like to talk about this P sine theta. How did I get this P sine theta is, see here, at this point, that is at the supports, the pre-stressing force will be acting, and it is pulled. Actually, I forgot to show that arrows here. So the pre-stressing force will be here as well as here. It will be in a inclined manner. If we convert or resolve that inclined force to two component, that is horizontal as well as vertical component, horizontal force will be H cos theta. For vertical reaction, it is P sine theta. So for horizontal, P cos theta, vertical, P sine theta. So we are considering that vertical reaction here, and as it is acting downwards, the reaction is acting downwards, we should consider it as negative. So the ultimate shear force at this, as I said, the shear force will be maximum at the supports. So consider this, it is acting upwards, 69.75 into 10 power 3, convert it into from kilonewton to newton, minus P sine theta. Okay. As we have reaction downward, it is negative. So therefore VU is equal to 69.75 into 10 power 3 minus P into 0.04. Still P is not resolved, keep it as it is. And in the question itself, they have given a statement that shear stress is 0. For shear stress, the formula is 2V is equal to VU into A into Y bar by I into B. Because of this shear stress condition, I am just equating 2V as 0. So this formula, substitute all the terms, VU minus P into 0.04 into 10.56 into 10 power 6, whatever A Y bar we have got, whatever VU we have got, I have just substituted everything here. After substitution, substitute for a denominator, I value is 4.57 into 10 power 9 into B is 200. We will, after resolving this or solving this, we will get P has 1743.75 into 10 power 3 Newton. Next is principal stress. As we know, 2V is 0, that is shear stress is 0. Consider that condition. Next we have a horizontal pre-stress. Fx is equal to P by A. We can calculate horizontal pre-stress by using a formula as Fx is equal to F is equal to P by A, that is load by area. Load, just now we have got 1743.75 into 10 power 3 whole divided by 200 into 650. We will get 13.41 Newton per mm square. Next is vertical stress. Vertical stress will be 0, so Fy is 0. Next is the calculation of principal stresses. For a calculation of principal stresses, the formula is sigma is equal to Fx plus Fy by 2 plus or minus 1 by 2 whole root of Fx minus Fy whole square plus 4 2V square is a formula. In the question itself, 2V is 0. So this 4 into 2V will be 0. This part won't be there. We know Fx, Fy is 0. So substitute the value, you will get sigma max as 13.41 Newton per mm square and sigma minimum is 0. First of all, how to calculate this sigma max is, the general formula is f of x plus fy whole divided by 2 plus or minus 1 by 2 into whole root of fx minus fy whole square plus 4 2v square. This is a general formula. When we want sigma max, we should consider this as positive. Okay. So take that positive value, take these two terms, then you will get 13.41. To get minimum value, sigma minimum, you should consider negative sign here. Don't consider positive sign, it should be negative sign. So after simplification, we will get 0. Like this, we can calculate principal stresses by using shear stress values, and we can find out pre-stressing force also. Hope you have understood this. Thank you.